Fine. So today we are going to talk about the Laguerre differential equation, and also the Laguerre polynomials. Now, since in the last few lectures we were discussing about the some of the different second order differential equations, like we talk about the Bessel differential equation, then we talk about the Legendre differential equation, and then we talk about the Hermite differential equation, and also their different polynomials. Now, another class of a second order differential equation is that is what we call as a Laguerre differential equation. Okay. Now, what is it like? So, Laguerre differential equation, if I will write down the Laguerre differential equation. So, Laguerre differential equations like x y double prime plus some 1 minus x y prime plus some integer n into y is equal to 0. This equation is what we call as a Laguerre differential equation. Now, this Laguerre differential equation actually occurs in the wave functions of hydrogen atom in quantum mechanics. Occurs in the wave function of hydrogen atom in quantum mechanics, right? So now you know that this is a second order differential equation. We can find out the solution to this second order differential equation like we find out for the so many second order differential equations, the series solution. So I'm not going to to discuss the solution of this particular differential equation because that is quite easy and that I'm giving you as an assignment. I will directly assignment because it's very simple. You have find out the solution to so many complex kind of a differential equation. This is the simplest of one. You can easily find out the solution. So how you can find out the solution? But the solution by the series method, power series method or Frobenius method in ascending powers of x. I'm giving you as an hint here in ascending power of x. What I mean, that means you write down the solution is like summation over m cm x raised to power m plus r. Fine.
सर नहीं
So
आ रहा है कुछ लिखे हुए
sorry,
डिस्प्ले नहीं हो रहा है कुछ जो
why?
आप लिख रहे हैं वो नहीं
सबके साथ ये प्रॉब्लम है और
नहीं सर दिख रहा आ रहा है
oh you have
नहीं
some
सर
सर
अब आया अभी तक नहीं आ रहा
अब
okay,
आया जी सर
okay, fine. So to find out the solution of this particular differential equation, you just do one thing. Just take this solution by series method in the ascending powers of x. So we have done it for so many cases and you can easily do it for this particular differential equation. This is the simplest of the differential equation. Now what will your solution look like? The solution to this particular differential equation will be like, since it's a Laguerre differential equation, so instead of y, we represent it by ln of x, right? So the general solution to this particular differential equation is given by some summation r running from 0 to infinity minus 1 raised to power r n factorial, n factorial, yes, divided by r factorial square, then n minus r factorial, n minus r factorial x raised to power r. Okay, this is the solution to the second order differential equation and we call this solution as Laguerre polynomial. Laguerre polynomial of order n. So by taking the different values of the n, I can find out the different Laguerre polynomials of order 0, 1, 2, 3 that I will do after a certain time. Okay, so this is a solution, but you have to find out the solution by the series method. You can do it yourself. So by taking it in as the ascending powers of the x. Okay. Now we will be discussing about this Laguerre polynomial and also as well as we will talk about them. We will talk about them. Then we will talk about other things like recalculation and the generating function. So I will just start with the generating function. Fine. But do find a solution yourself. It's very simple. Generating function. Like we had the generating function for Bessel, for Legendre, and the Hermite. Similarly, we will consider one of the function, and we will see whether we can really generate these Laguerre polynomials from that very from that very function. And if it's so, then we will call that particular function as the generating function for the Laguerre polynomials. So the generating function, the generating function for this Laguerre polynomial is given by some function which is a function of x and t, and is given by 1 divided by 1 minus t, then e raised to power minus xt divided by 1 minus t. Okay, so we'll see whether this will generate this Laguerre polynomials or not. So this should generate some n running from 0 to infinity ln of x t raised to power n. So the coefficient to this t raised to power n are actually these Laguerre polynomials. So for this t less than 1. Okay, so let us try to find out whether we can have these Laguerre polynomials from this particular function. So I will consider this function 1 divided by 1 minus t e raised to power minus xt divided by 1 minus t. Okay, I will write down this as c. I can write down this as 1 divided by 1 minus t. This is like e to power x, right? And you know that the power series of this x, e to power x is 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on. So I can write down this as like summation some r running from 0 to infinity 1 by r factorial, right? Then x raised to power r, for example, or simply x raised to power r divided by r factorial. But instead of x, we have xt by 1 minus x. So how I can write down this solution is, so I will write down this as 1 divided by 1 minus t summation some r running from 0 to infinity, okay, 1 divided by r factorial. Now instead of x, what we have? We have xt divided by minus xt divided by 1 minus t raised to power r. Fine. Okay, so let us try to expand this part. What I will do, I will write down this as summation some r running from 0 to infinity. This 1 by 2, I'm going to take it inside. I will write down this as 1 by r factorial, and minus 1. When I'm going to take it out of this, it will be minus 1 raised to power r, then xt raised to power r. Okay, we have the 1 divided by 1 minus t into 1 minus t raised to power r. It will be 1 minus t raised to power 1 plus r, or r plus 1, right? Okay, or I can write down this as again summation some r running from 0 to infinity 1 divided by r factorial minus 1 raised to power r. Then I will write down this as 1 divided by 1 minus t raised to power 1 plus r. I can write down this as r plus 1. R plus 1 is more convenient to write. Then I will write down this as t raised to power r, then x raised to power r. Fine. Okay, or I can write down this as summation some r running from 0 to infinity 1 divided by r factorial minus 1 raised to power r. I will write down this as 1 minus t raised to power minus r minus 1. I am going to take it here, so it will be minus r minus 1 into, okay, also we have t raised to power r here, then x raised to power r. Fine. Now you know that this 1 minus t raised to power minus r minus 1, you know that I can write down, if I have some 1 minus x binomial expansion, 1 minus x raised to power minus n. How I will write down this as, or I can say 1 minus x raised to power m. This is always given by 1 plus some this is minus, so it will be m x plus m into m plus 1 divided by 2 factorial x square plus m into m plus 1 into m plus 2 divided by 3 factorial x raised to power x cube, so on, plus the last term will be some summation over m, some summation over s, then m plus s factorial divided by m factorial into s factorial x raised to power s. This thing. So using this thing, I can write down this as 1 minus t raised to power r minus 1. You just tell me how I will write down this as. So this equation, I will write down this as equation, some r running from 0 to infinity. Okay, let me write these terms first. I will write down this as 1 divided by r factorial minus 1 raised to power r. Then I have t raised to power r is there and x raised to power r. So how I can write down this is 1 minus t raised to power r minus s. I will write down this as summation s running from 0 to infinity. Okay, instead of 1 minus x, I have now 1 minus t. So I will write down this as r plus s raised to factorial divided by r factorial s factorial. Fine. Then t raised to power s, because we have the t. So instead of t here, I am using this as x, binomial expansion. Fine. Okay, now if this is okay, then what I will do, so I will say that this particular equation here, so let me write it on the next page. So I will say that this thing, this equation, I will just combine these two terms, see how I can combine. So instead of going it on the next page, I will do it here, because you should have an eye on this also. Okay, I will write it here because आपकी नजर इस पे रहनी चाहिए जो जहां से मैं ये लिख रहा हूँ. Okay, see this equation. So I will write down this as equation as some summation r running from 0 to infinity, summation s running from 0 to infinity. Fine. 1 by minus 1. I will write down numerator part first. Minus 1 raised to power r. Then I have r plus s factorial minus 1. Then r plus s factorial. The r factorial into r factorial, that is r factorial square. R factorial square, then we have s factorial. Okay, then we have x raised to power r, and then we have t raised to power r plus into t raised to power r plus s. Okay, now I will put this r plus s is equal to n, right? So that means, implies this s is equal to n minus r. Again, so if that is the thing, that the limits will again also going to change. So I will write down this as t raised to power n. So this particular equation, I will write down this as summation r running from 0 to infinity, instead of s, because s will go from n to r, it will be n running from 0 to infinity, minus 1 raised to power r plus s is n factorial, right? R plus s is n factorial divided by r factorial square. Okay, then s is n minus r, it will be n minus r factorial. Okay, then x raised to power r into t raised to power n, t raised to power n. Fine. Okay, but we have अभी मैंने ये कहा था कि this summation n running r running from 0 to infinity minus 1 raised to power r n factorial, this is a Laguerre polynomial. Okay, so you can write down this equation as, so you write down this as summation n running from 0 to infinity. Instead of this, I will write down this as including this summation. This is ln x t raised to power n. Okay, so this is actually 1 divided by 1 minus t e raised to power minus xt divided by 1 minus t. So we find out that this particular function actually generates a, so the coefficient to this t raised to power n are nothing, they are just the Laguerre polynomials. Okay, so we find out that this function is a generating function because it will generate your Laguerre polynomial. Okay, so this was all about the generating function. We have done it for so many cases. So this is the simplest of all those cases to find out the generating function. But if you go back to the previous cases where the Legendre function, Legendre as well as the Bessel, the generating function, to find out the generating function was not that easy as it is here. So it's very quite easy to find, say, to check whether this function will really generate a Legendre, this Laguerre polynomials or not. So we will consider this function to be as a generating function, to be as a generating function. So it will generate a Laguerre polynomials of order n. that is the coefficient to this term t raised to power n, are the Laguerre polynomials. Fine. Now, if it is okay, then let me directly jump to the reconciliations. Before going to the orthogonality of the polynomials, let us do some of the reconciliation. Reconciliations of these Laguerre polynomials. Okay, the first one is like n plus 1. These reconciliations are used to solve many problems in the physics, because we can substitute. If I have some Laguerre polynomials of order n plus 1 or n minus 1, I can use this reconciliation to find out the solution to those physical problems in quantum mechanics, like for example, we were solving the hydrogen atom problem. Okay, so this n plus 1, ln plus 1 of x is equal to 2n plus 1 minus x ln of x minus n minus 1 of x. Okay, we have to prove this reconciliation. So how we will prove it? Again, we will start with a generating function. So I will say that since 1 divided by 1 minus t e raised to power minus xt by 1 minus t is equal to some summation over n running from 0 to infinity ln of x t raised to power n, जो we find k. So what is the next step I will do? I will just differentiate this equation with respect to t. Differentiate with respect to t. Differentiating with respect to t. So this is actually 2u into v. So see how I will do the differentiation. I will first keep this term as such, 1 divided by 1 minus t. And you know the differentiation of this e to power x is e to power x. So differentiation of this is e to power minus xt divided by 1 minus t into the differentiation of this xt by 1 minus t. So what is the differentiation of xt by 1 minus t? See, I will do it here, then I will write it directly here. So d by dx of this xt by t 1 minus t, right? So I will keep x out because it is constant. I have to take differentiation with respect to t only. I will use x later. So, or I can say that x into d by dt. So I will do it like 1 minus t into differentiation of t is 1 minus then t into the differentiation of this is minus 1. Okay, so it will be 1 minus t plus t. So this and t will cancel. Okay, divided by 1 minus t square. Okay, this, so it will be 1 minus t square, and x is also there, so it will be simply x. So I will write down there this as minus x divided by 1 minus t square. Okay, right, fine, plus. Now I will keep this thing and I will just take the differentiation of this. So I will write down this as, what is the difference in 1 divided by 1 minus t? It will be simply 1 divided by 1 minus t whole square e to power x minus xt divided by 1 minus t. Why? Because d by dt of 1 divided by 1 minus t, it will be again 1 minus t into 0 minus 1 into minus 1 divided by 1 minus t whole square. So this is minus 1 into minus 1, it will become plus. So it will be 1 divided by 1 minus t square. Simple. So that's why I take it said 1 by 1 minus t into e raised to power xt. Fine. So this will be equal to now summation n running from 0 to infinity. Ln of x will remain as such because it is a function of x, but here it will be n t raised to power n minus 1. Right? Fine. Okay. Now, or what I will do, I will just multiply throughout by 1 minus t square. Multiply throughout by 1 minus t whole square. Okay, so what will this become? Let me write this term as first. So when you're going to multiply, it will be e raised to power minus xt divided by 1 minus t plus, okay, 1 minus t. So it will be now, we have here 1 minus t square. यहाँ पे 1 minus t square and 1 minus t. 1 minus t will get cancel out. So it will be 1 divided by माइनस टर्म माइनस x is यहाँ पे है, so I will write down this as minus 1 divided by 1 minus t, because 1 minus t square will get cancelled जो मैं multiply करूंगा यहाँ पे, then e raised to power, okay, but x is also there, so I will write down this as x divided by 1 minus t e raised to power minus xt divided by 1 minus t. Fine, this will be equal to, now multiply here, it will be 1 minus t whole square into summation the ln of x and ln of x t raised to power n minus 1. Fine. Okay, now let's try to further simplify it. I will just write down this as hmm, what I will do, I will just okay. Now see, अगर मैं यहाँ पे इसमें 1 minus t न्यूमरेटर में एंड 1 minus t दोनों न्यूमरेटर एंड डिनोमिनेटर में इसको मल्टीप्लाई करता हूँ, राइट? सो आई कैन राइट डाउन दिस एज 1 minus t into what is this equal to? So I will write down this as 1 minus t. Instead of this, I know this is this thing. So this is summation over n, ln of x t raised to power n simply. Okay, minus x into यहाँ पे मेरे पास 1 minus t already है. So I will write down this as n, ln of x t raised to power n. Fine. Okay, here I will write down this as 1 plus t square plus 2, sorry, minus 2t into summation over n running from 0 to infinity n ln of x t raised to power n minus 1. I hope you are getting all these things. Okay, see, we have two different terms here. One will be simply summation over n ln of x t raised to power n. Other is when I'm going to multiply it to minus t, it will be minus summation over n ln of x then t raised to power n plus 1. Fine, minus x summation over n ln of x t raised to power n. This is I'm writing it as such. Okay, here we will again have three different terms. So one term will be summation over n ln of x t raised to power n minus 1. That another term will be plus summation over n ln of x t raised to power n plus 1. T square n minus 1 into t square, that will be n plus 1. Fine, plus, okay, minus, now it will be twice summation over n ln of x t raised to power t into n plus 1, that is simply t raised to power n. I hope you are following all these steps. If you are not getting it, please let me know. Instead of switching to the next page, I will write it here because I need to have a look at this particular equation. Okay, now you know what we use it to do. Now I will equate the coefficient of t raised power n on both sides. On equating the coefficient of t raised power n on both sides, you know how we do that. जहाँ पे आपका t raised power n है, वहाँ पे हम as such रखेंगे. जहाँ पे n plus 1 है, we will make n equal to n minus 1. जहाँ पे n minus 1 है या n minus 2, we will just try to make the coefficient equal to. So equating coefficients of t raised power n on both sides. Okay, so on equating the coefficient of t raised to power n on both sides, I will write down simply here as t raised power n. On the left hand side, it is ln of x. T raised power n, it will be n equal to n plus n minus 1. So it will be minus ln minus 1 of x. यहाँ पे minus x ln of x. Okay, this will be equal to n ln of x. Oh, sorry, n. यहाँ पे देखिए, so this is n minus 1, so I will make n equal to n plus 1. So I will write down this as n plus 1 l n plus 1 n plus 1 of x. Okay, it is n plus 1, so I will make n equal to n minus 1 plus n minus 1 l n minus 1 of x. Okay, minus 2 n ln of x. Okay, now we will try to look at this, what we are supposed to find out. So in order to find, I will just rearrange these terms. I will try to bring it in this form. First, I will see, is there any common term? Okay, yes, we have. Like we have this 2n ln of x and ln of x and ln of x, right? So how I write down this, all these things? I will take this 2n here and also this x term here. So या आप यहाँ पे ले लीजिए या यहाँ पे लीजिए, that is one and the same thing. So what I will do, I will write down this as 2n, this 2n plus 1 minus x into ln of x. Now this term and this term, they are gone. Okay, minus, okay, now we have this ln minus 1 and n minus 1 ln minus 1. So what I will do, again I am going to take it here, so it will be minus, I can write down this as, I will write down this as plus, and then I will write down this as minus 1. This will be minus n plus 1 into ln minus 1, sorry, n l minus 1 of x, ln minus 1. So this term and this term is again gone. So I will write down this as equal to n plus 1 ln of x, n n plus 1 of x. Okay, now this plus 1 and minus 1 is gone. So or I will just keep it in the left hand side. I will write down this as n plus 1 l n plus 1 of x, okay, will be equal to 2n plus 1 minus x l n of x minus n l n minus 1 of x. Now see, if you look at this equation, this is what we were supposed to prove. So from the generating function, we proved this recalculation. Okay. Is it okay? Or if anybody has some doubt in getting any of the equation or any of the point, please let me know. It's very simple. It's not that tough. All you need to just rearrange the terms, taking the differentiation of a generating function, this particular equation, then the rest of the things will follow. Okay. Now let me quickly take another reconciliation. The relation is like second one. We have to prove now x ln prime of x is equal to n ln of x minus n l minus 1 of x. Okay, so what you will do, I'm quickly going to give you some guess, and rest of the things you will do yourself. Okay, so see what you will do. Just again consider the generating function 1 divided by 1 minus t e raised to power minus xt divided by 1 minus t. Okay, is equal to some summation over n ln of x t raised to power n. Now here just take the differentiation with respect to x. So when you are going to take the differentiation of, with respect to x, it will be 1 divided by 1 minus t. It will serve as a constant. It is simpler than the previous case. It will be e raised to power minus xt divided by 1 minus t, then into t divided by, sorry, minus t divided by 1 minus t, because differentiation of x will be equal to 1. So it will be equal to summation over l ln prime of x t raised to power n will remain as such. Okay, or you just write down this, because you know that this is a generating function. So I will write down this as minus t divided by 1 minus t summation over n ln of x t raised to power n will be equal to summation over n ln prime of x t raised to power n. Okay, I'm quick because this is very simple, and you just give it a try later yourself. Okay, so now what I will do, I will just again multiply this 1 minus t on throughout. It will be 1 minus t summation over l ln of x t raised to power n will be equal to 1 minus t यहाँ पे 1 minus t summation over n ln prime of x t raised to power n. Fine. Okay, so now see, this will be minus summation over n ln of x t raised to power n plus 1. This will be equal to summation over n ln prime of x t raised to power n minus summation over n ln prime of x t raised to power n plus 1. Fine. Again, equate the coefficient of t raised to power n. Just equating the coefficient of t raised to power n, it will be here n equal to n minus 1. So it will be l n minus 1, but minus l n minus 1 of x will be equal to Shamash, ln prime of x. Ln prime of x, here n will be equal to minus ln minus 1 prime of x. Right? You just name this as equation first, because we have to prove something else and it's quite different. So how we will do that, I will just do one thing, or before that I will just try to ये minus sign जो यहाँ पे है मेरे पास, I will just try to, I will write down this as simply ln prime of x will be equal to, यहाँ पे मैं ये यहाँ पे लिख रहा हूँ ln minus 1 prime of x, ये यहाँ पे minus ln plus 1 of x. इसका नाम आप फर्स्ट रखिए, माइनस साइन, इसका नाम आप फर्स्ट रखिए. Okay, see, now from the first reconciliation, which is like from the first reconciliation जो हमारे पास है n plus 1, l n plus 1 of x is equal to 2n plus 1 minus x raised to power n, sorry, ln of x minus n l n minus 1 of x. Right? इसको आप क्या करेंगे? You just differentiate this with respect to x. इससे क्या होगा? It will be like n plus 1 ln plus 1 prime of x. This will be equal to 2n plus 1 minus x, then ln prime of x. Again, the another term will be ln of x into the differentiation of this thing. So ये यहाँ पे minus 1 आ जाएगा इसको. So it will be minus ln of x minus n ln minus 1 prime of x. ये स्टेप जरा यहाँ पे पूरा देख लीजिएगा. So now what I will do, you just name these equations also. Name this equation as equation, this as equation 2 and this as equation 3. Right? Now what I will do, I will use equation 1 in this. Equation 1 यहाँ पे मैं use करूँगा. What is equation 1 by the way? आप equation 1 पे देखिएगा. I will use equation 1 here. So using equation 1 quickly, because the meeting is going to end in some 3 minutes, I want to finish it. That's why I'm a little fast. Okay, so now using equation 1 क्या है हमारे पास? ln यहाँ पे, sorry, ln prime of x. So using l equation, if I will going to substitute n equal to n plus 1 this equation यहाँ पे, so ये क्या बन जाएगी? It will be ln plus 1 prime of x will be equal to ln prime of x minus ln plus 2 of x by substituting n equal to
सर ये n plus n minus 1 था, n plus 1
Sorry.
कैसा है?
नहीं माइनस ही है यहाँ पे. It's minus here, हाँ? ये माइनस है यहाँ पे, प्लस नहीं है, माइनस. So it will be l n of x and minus l n. ये यहाँ पे माइनस ही है, ये गलती हुई है यहाँ पे, ये माइनस है, l n minus 1, n minus 1 ही है. So it will be ln prime x minus ln. Okay. So now what will be this equation become? So instead of ln plus 1 prime के बदले में ये सारा equation यहाँ पे दे दूंगा. So I will write down this as n plus 1 ln prime n plus 1 prime के बदले में क्या वैल्यू दूंगा यहाँ पे? Yeah, before that what I will do, I will just multiply this equation by n plus 1 throughout. So I will write down this equation as n plus 1 ln plus 1 prime of x is equal to n plus 1 into ln prime of x minus ln of x, n plus 1. Okay, now ये जो है यहाँ पे ln plus 1, we have this equation here. So this equation, you just do one thing. Instead of this equation, what I will do, I will just substitute this right hand side. So this equation 3 will now become, I will just name this as equation 4. Then write using equation 4 in equation 3. In equation 3, you just use this equation in equation 4. The equation will now become 2n plus 1 minus x ln prime of x minus n ln minus 1 prime of x will be equal to this left hand side. I will write here directly. So it will be n plus 1 ln prime of x minus n plus 1 ln of x minus ln of x. So using this equation 4 in equation 3, you can see you will get this particular equation. So now I just on simplification just rearrange the terms. यहाँ पे this is the final step. On rearranging the terms, you will get this particular equation. Okay? So this again I am giving you as an assignment. So rearrange these terms and you will arrive at this. This is the final step. Here I am using this equation 4 in equation 3 and you will. So on simplification, on simplifying or rearranging, simplifying, you will get this particular equation. So this again I am giving you as an assignment. You just try to find out. Do log in again. So this is going to end in a few seconds. Do log in again and I will listen to your questions or some queries if you have any.